Let us see what is called separation of X. Here X means topological space, okay? So first you have to consider a topological space. Here this is the topological space, okay? This is the topological space, X. Within this topological space you are having two disjoint open subsets, okay? What you are having? You are having two disjoint open subsets. They are U and V. I am going to say this U and V are separation of X. To say that there are some conditions, that conditions should get satisfied, then only you can say this U and V are the separation of X. Let's see the conditions. Here you have three conditions. What is the first one? When you find the union of U and V, we know how to find the union, right? It is very basic. So when you find the union of U and V, you will get an answer, right? That answer should be equal to X, okay? For X there will be a value. Likewise, when you find the union of these two disjoint open sets, you will get an answer. That answer should also be equal to X. That is the first condition, okay? That is the answer you get from here will be equal to this, okay? Then you can say what? The first condition to say separation of X is satisfied. This is the second condition. Here you have two disjoint open subsets of X, right? They are U and V. The U should not be empty and V also should not be empty. There should be any elements, okay? It should not be empty. It should have some elements. That is what the meaning you will come to know from this point. And the third condition is when you find U intersection V, it should be empty. We know that this U and V are disjoint open subsets. We know if they are disjoint, what does it mean? They are not having any common elements. That is what the meaning, right? So the third condition is when you find the intersection of these two open subsets of capital X, you will get empty. It means you don't have any common elements in U and V. If these conditions are satisfied, then you can say this U and V are separation of X.